Okay, so another Leetcode practice question, pretty easy one. So in this video, two goals. The first one is to find a solution and put some code in place. And the second one is to see how to behave during interview. Suppose this kind of question is given. So let's get started. The first step is to try to understand the problem and also ask some clarification questions if you are not clear about some parts, and also try to think about some edge case at the very beginning, which are quite special. So let's take a look at this question. So given root node of BST, return the sum of value of all nodes with a value in the range low to high. Okay, so let's say example, let's say we have this tree and low is 7, high is 15. Then of course we are going to add up 7, 10 and 15 together, which is going to be 32. Okay, so let's see some constraints. So the value of each node is between 1 to 800,000, and low and high has similar range, and the number of the nodes in the tree is in the range of 1 to, okay, so the number of nodes is between 1 to 20,000. Okay, and all the node value are unique. Alright, so there's no duplicate numbers. Okay, was it really helpful? Okay, let's see. So the next one, after we find what we are going to do with the question, it's time to find a solution for this question. So BST. So BST, we understand what the BST is. So all the nodes to the on the left subtree is smaller than the root node, the value of the root node, and all the values on the right subtree is larger than what the value is in the root node. So I think we could just use a DFS. We could use DFS to solve this problem using recursion. So I would say the worst case, still it is going to be all of n. N is defined as the number of the nodes within the tree, because if the low and high contains all the nodes within the tree, then we need to sum up all the nodes. So that's the worst case. And then let's put some solid code there. So in the code part, we care about the speed. Don't be too slow turning your idea into code, and also the correctness of the code, and also the readability of the code. So let's see, for this one, it says that low is always smaller or equal to high, so we don't need to deal with those kind of special cases. So let's say if root is a non-pointer, then we will definitely return 0. So if the root node is within low and high, the value is larger or equal to low, and root value is smaller or equal to high, then we are going, let's say okay, so we first define some sum as equal to 0. Sum is equal to root value. Alright, and then we are going to visit the left subtree and the right subtree. So sum plus equal to range sum BST, root left and low high, and sum plus equal to range sum BST root out right, low and high. So suppose root value is actually smaller than low, then actually so if it is smaller than the low, then we actually just need to visit the right subtree. So if root value is smaller than low, then what we need to do is we only need to visit the right subtree. Root dot right, low, high. Okay, else we only need to visit the left subtree. Range sum BST root dot right, low, left, low, and high. Okay, and finally we return sum. So that's it for this piece of code, and let's do some testing for it. So let's take an example for example 1. So first of all, it is a root node. It's definitely within 715, so sum is equal to 10 at this moment, and we are going to this stack. For when we visit the left subtree, we see that 5 is definitely smaller than 7. So what we would do is we will just visit the right subtree. So it jumps into this place, and when root is at this node, it is going to jump into this if branch, and the sum is equal to 7 now, and we return 7. And this branch is going to return 7 to this one, and then we have 17 here, and then we write with the right subtree of this root node, and then we see that okay, when it jumps into this one, it is 15. 15 is within the range, so it is jumping to this if branch, and we currently have the sum temporarily set as 15, and we are going to, when we jump into the left branch, it says root is equal to none, then you return 0, and for the right branch it says that it is out of the range. 15 is definitely larger, 18 is definitely larger than 15. Then it is, when it jumps into another function, recursive function, it is going to be this else branch, which means we only need to visit the left subtree, but the left subtree for this node is empty. So all in all, it is going to return 15 in here. So 17 plus 15 is 32, so finally we return 32. So I think it mostly looks good. Okay, so it's accepted. Let's give it a submission. Okay, so it's good. So like I said, definitely do some testing and explain how it works using one example. And also for this question, I would say use try to understand. First of all, try to understand it is a BST, and try to leverage what is specific to what is special in BST. Like for this one, you can definitely cut some branches to save some runtime. So that's it for this coding question. If you find it a bit helpful, please give me a thumb up, and I'll see you in the next video.